As long as it fits in 30 minutes, we're good.
Good afternoon, guys. So today, myself and Raghavendra Bhat will be talking about cluster volume snapshots. So we'll talk you through how the feature works and what are the various sub-features in that, and also what we are planning to do further in due course of time. So this is the agenda. Basically, I'd like to go through the introduction and then right now the supported configuration, accessing snapshots. How do you access snapshots? Some additional new features which is implemented recently, future work, and followed by Q&A. So if you have any questions, I think please let me know. I can take any time. Snapshots in Gluster introduced in Gluster 3.6 is based on purely on LVM2. So the backend, the file system should be LVM2 capable and should be hosted on thinly provisioned volumes. And snapshot. So basically, you have a Gluster volume and you take a snapshot. So snapshot will create another volume, so which is a snapshot of the original volume. And this particular snapshot of volume is a read-only volume. So I'll go through in the supported configuration what is the prerequisites for taking snapshot and how in which all systems you can take snapshots. Other important thing in snapshot is crash consistency. So basically these particular snapshots are crash consistent. So we are not covering the application crash consistency here now. The application need to take care of their data part. So if they want to the data which we saved inside in the snapshot, so they need to sync it explicitly. So right now we are not providing a hook wherein when a snapshot is taken, the application can flush it. So that will be considered in future releases where we can provide some kind of hook where snap-aware applications can ask, when the snapshot will be taken and they can sync the data. So right now what we are talking about is consistency in the file system, that is the cluster layer. So when we take a snapshot, the snapshot should be in a consistent state or can reach to a consistent state. So if you have taken snapshot, the IOs and various operations are going on. So at the point of time, snapshot is a point in time copy of the cluster volume. So the IOs are going on at that point of time. Some of the, since most of the IOs are not very atomic in nature, so there might be cases where you have taken snapshots and some of the IOs are half-written or things like that. So we need to make sure that when the snapshot is taken and after that when you use it, you can reach to a consistent state, or whatever there, it is already in a consistent state. So I'll go through how it is done. So this is a very good example of how cluster volume looks like. The volume is formed out of various storage nodes, and each of the storage nodes can host one or more bricks. So bricks are distributed in various nodes. So as I said, the current snapshot implementation is based on thinly provisioned LVM. So you have your storage devices, you form a volume group out of that, and you bring a thin LV. So normally thin LV is made up of, you need to have a pool to create a thin LV. And when you have an LV, normally you create a brick out of that. So what happens when you take a snapshot? So our snapshot is dependent on the LVM snapshot. So when you take snapshot, it just creates an same copy of the LV or whether the brick is there. So it is the LVM is copy is made in the same input. So this is how in the backend LVM works. So now we have to map this to the cluster usage. So this is, as I said in the previous diagram, we have a volume, we have bricks hosted in multiple nodes. So whenever a user issues a snapshot command, so normally there are in the backend we go through various stages. So the CLI passes the command to the cluster team. the class ID where the command is executed is called the originator node, and in our system, snapshot is most of the command runs. It runs in various stages. We have pre-validate state, we have a commit state, and post-validate state. So all these phases first normally run on the originator node, and followed by this is spread across to all the nodes. So snapshot is also follows the same pattern. Whenever the application, when the admin says take a snapshot, it goes and follows various steps to take a snapshot. So as I said, crash consistency is one of the prerequisites for that. So some of the efforts which can lead to inconsistent behavior, so we need to somehow stop those particular efforts for a while. So that's why we introduced something called as barriers. So the first step when something happens, snapshot command is issued, the first thing is that all the bricks we take a barrier. So barrier is a new translator written with the Gluster. So what it does is that it holds the efforts in the return path, so that few efforts which can lead to inconsistency can be held back, and we can take or proceed with snapshot. So first thing is the barrier part. Once the barrier is done, we will proceed with each particular brick and issue a snapshot, individual snapshot command. So that will create equivalent bricks for the snapshot volume. So once you, so these are the bricks for the original volume. So when we take a snapshot, it creates a element copy. So once you have copies of all the bricks, you create a volume out of that. So this forms a snapshot volume. So snapshot volume have the same configuration, whatever the cluster configuration, the volume configuration at that time of snapshot, it will have the same copy. So if you have various options set and volume and everything will be reflected in snapshot. So that will have this exact same copy. So this is a very general overview of how snapshot works. So I like to just give us a little stress on how the supported configuration right now. So I think, as I said, it is based on thinly provisioned LVM. So that means all your bricks should be on an independent thin LV. And previously we used to have, we can have a single LV, it can be thinly provisioned or can be normal LV, and we mount it and create subdirectories and as many subdirectories as possible, and we can have as different bricks. But going forward to have snapshot, this particular configuration is not supported. So I think we'll go to the next one where I can give an example. So this is an alter configuration where you can see you have bricks, you can have LV, or you can have direct bricks. You directly mount it and you can create mount the board and create multiple bricks out of that mount. So this was the older configuration which is no more supported going forward from 3.6 to take advantage of snapshot feature. So this is now the recommended configuration. That means each particular brick should be created out of an independent thin LV. So that means it should have an independent pool. So you have to manage that particular. And important thing is that the pool size and the pool metadata size should be managed accordingly, because when the bricks are hosted on an LV and when you take snapshots, it consumes the space from the same pool. So if you are taking a lot of snapshots, it will consume some of the metadata and the storage from the same pool. So administrators should basically monitor the usage of the thin pools and the backend storage. Okay, and so basically now we have created snapshot. How can we access them? So basically we have two ways by which you can access it. So as I said, snapshot is nothing but a copy of all your volume, so you can directly mount it. You can mount using the native use command. So this is a slightly different syntax. So you need to tell that you are mounting a snapshot. So you need to tell, so this is a host name followed by a snaps, and you should say what is the snap name you are mounting, followed by, and you should tell what is the original volume for that. So once you said, you can mount it. So So right now we only support fuse mount, NFS, and SIPS mount is not supported as of now. And the other method for accessing is user serviceable snapshot, which Johnny will tell you in detail.
So, as Rajesh said, like snapshot data, whenever a customer volume snapshot is taken, data has to be accessed, and there are two ways. One is, as we said, like you can mount the snapshot volume, but the main issue with it is that like whenever you mount the snapshot, you need admin intervention. So someone has to mount it, and then you have to get it. Instead of that, another easier approach that can be used is user serviceable snapshots, where the users themselves can access the old snapshot data and get the whatever data. If say that they delete accidentally some file in their directory or change something that was not needed, then they want to have a good copy of from past, then they can get it. So that's the purpose of user serviceable snapshots, which is mainly ease of use. So without admin intervention, you can use it. So you can how it works is you can treat it as like if I have to tell in physics terms, if your regular volume is like so space time means like your regular value, you have different files or directory. At this point of time, you can see different space. If you go into the snapshot or user snapshot, you can look at one particular directory at different intervals of time. It's like looking at the same file or same directory at different intervals of time. I want to see what is happening, what was the state of this particular directory at this point of time, or when that snapshot was taken. So that's the main purpose of user serviceable snapshot. So how it can be accessed is that like in every directory, including root of the volume and in every subdirectories, there will be a hidden directory called .snaps. Okay. By default, the .snaps is configured as well. So by default .snaps. So whenever you cd to it, and if you do ls, you can see a list of directories which are nothing but the names of the snapshot that have been given by the user while taking the snapshot. So a list of contents which is like a directory which represents that particular directory from where you have entered .snaps when the snapshot was taken. So it will be like cd from root, if I have to do root of the custom on .snap, and see say that there are 5 snapshots and snap 1 to snap 5. You see, if you enter snap 1, then it shows the state of the volume when the first snapshot was taken. If snap 2 means the state of the volume is the second snapshot was taken, and it's not just for root, it's for every directory. So which helps like as said, the main purpose is to avoid admin intervention, and in this situation users themselves can access their files. And here also, the access is read only, writes are not allowed. So only read, and you can copy the files from the snapshots if you have accidentally deleted it, or you can even go through what was the situation, what was the state. You can trace how something has grown. Those kind of things can be done by a snapshot. So how do we achieve this? Is like in each node in the structure storage pool, we will be having a daemon. We call it a snap daemon. So that is the one which gives the view of the snapshots. For that we have to introduce 2 translators. One is we call it as SnapView client, and another we call it SnapView server. Where SnapView client translator sits in the client stack, where NFS server or fuse client qualified. There it sits. Whose 2 subvolumes or 2 children, it can have only 2 children. One of the child is the main regular subvolume or regular volume. Another is the snapshot. So it is via the SnapView client, it talks to SnapDaemon, which has got a SnapView server, and it like using GF API, it talks to each and every snapshot of that volume. So in snapshot daemon, it's like there are 5 snapshots. It's equivalent to like snap daemon, which we're talking about all the 5 snapshot volumes. And whenever user say that enter dot snap, cd dot snap, a lookup comes on the dot snap, or some access comes. So then the Snap client is intelligent enough to decide where the request should be sent to. Should it be sent to Snap daemon, or should it be just forwarded to the regular volume? So that's the job of the client, Snap client. So it actually redirects based on if it's the regular volumes. They say that you are just creating a file, or you are just reading a file on the regular volume, then it just sends to the regular volume. So it can identify. So anything within dot snap starts from dot snaps, or that entry point directly to snapshot world. So it redirects to Snap daemon. And Snap daemon, which upon getting the request from the Snap client, all it does is like first it has to identify which snapshot it belongs to. So it identifies that particular snapshot volume and it talks to that snapshot or about that particular whatever file that has been accessed. So it requests the data and it gets it and gives it back to the snapshot. So this is how, and the advantage of this is like it's not just Fuse, it's both NFS, even Samba or Sys as well. So it can be user-specific snapshots can be used even via NFS clients or Sys clients. So irrespective, especially NFS and Fuse, the behavior will be almost same. Apart from the fact that if NFS client caches something, so say that you had accessed some data about a snapshot which was deleted. So in that situation, probably if you immediately try to access it, then it might give you some cache information. But if you just come out of the directory and then start from the cd dot or doing a drop caches, that's a small thing about NFS. Apart from that, Fuse and NFS are almost similar in behavior. In Sys, especially when it comes to Windows, what we had to do was like we had to make it. So the thing is like the .NET directory is so hidden that even ls-a won't show it. It's so hidden. The main purpose of it, someone does copy cp minus or something like that, where hidden entries are also considered. If someone is doing that on Gluster mode, where user-specific snapshots are enabled, then the user will be copying actually entire user snapshot data, which we don't want. We don't want only the actual volumes data. So that's why .NET was made hidden, so that even read replies don't be sending that entry. But see, if we are accessing from Windows, we need an entry. We need an icon to click so that we can enter it. So that was the major problem in Windows, because since read was not returning it, how to make it accessible. So for that, we brought in a new option which Samba plugin, GFAPI plugin that we have got Samba. Samba plugin enables that option so that the Snapview client will understand that it is being used by a Samba client or Sys client, so that only when a read request comes on a directory which has been exported to the Samba users, it might not be the root of the volume, it might be a subdirectory, but if it has been exported to the Samba, then it will add, Snapview client will add a .snap entry while sending the read response. It will virtually add it and send it, so that the users can enter that .snap. So this is how it is as of now. So the thing is like in future, how user-specific snapshots are enhanced. It mainly depends upon the changes, future work that are going to happen in the snapshots. Like they go hand in hand. Any changes in snapshot might need a changing even user-specific snapshots as well. For example, if you want to support shadow copy, where from Windows user wants to access different versions the same file without even going through .snap directory, then those changes can be made. Or probably we can even, if overlay comes into picture in future, we can think about how we can overlay as well to use this. So they are some of the things that can be it mainly depends upon the changes that are going to happen in the how the snapshots are used. So whichever actually Rajesh. Thank you.
So apart from that, there are a few more sub-features been introduced recently. So one of them is snapshot clone. Exactly, it is not a complete clone; it's a space-efficient clone. That means the backend is shared. It's not a complete clone where you can move into the different disk and save that. So this is one of the primary requirements from the money learning. So they can create shares after the snapshot. So they need a writable share from an existing snapshot. So this particular functionality provides you that part where you have a snapshot, you can create a writable volume out of the same volume. So it creates it's exactly like a snapshot, but it is a writable snapshot. So whatever the volume is in that particular state, in time, when you create a clone, it creates a copy. But remember, this is not a complete clone, so your disk is in the backend is shared. So that is a clone functionality. Also, we have introduced scheduling, which is normally is internally implemented based on cron. So cron normally runs on a single system. So we have made a distributed cron where multiple nodes and whatever the nodes is participating will coordinate with each other and take snapshots based on the schedules provided by the user. And the schedules is normally given by a tool, so it is not directly implemented in Gluster days add-on, provided as an additional tool. So normally you can keep the same syntax which is used by the cron. So you can specify the day and hour, the month for scheduling snapshot. The syntax are exactly same as the cron syntax.
Does it actually run through cron? So if you, for example, put like mail options in that, it would actually email out to people the same that cron does? So does it actually run through cron?
Yeah, it actually runs through cron.
So if a person puts like a mail options, it can actually send email directly from that? Because cron enables that.
Yeah, so you can do that. So basically, it directly uses cron. So this just gives a front end to manage that. Apart from managing that, it is distributed. So it is not only one machine which is taking the decision. Reason being, when you're scheduling, your nodes can go down. So if you're relying on one of the nodes to take a snapshot, you might lose the data. So one of the nodes is down, the other node will take the ownership and go and schedule it. So this is continuously run. So one of the changes which has been introduced, particular snapshot scheduling is a meta volume. So the whole management or the logic, the data which is stored in this shared particular volume. So this particular meta volume is shared by multiple other components for their work as well. So this is a new change which is coming in 3.7, like Jira and NFS also uses this particular shared volume for managing their data consistently. So the scheduling also uses this particular volume. So apart from that, generally we have other commands like creating a snapshot, delete, info, status, configure and restore. So it does the basic snapshot functionality. So I'd just like to highlight a few of the configurations which we provide. So we have something called as hard limit. So we can set a limit or volume or a global limit where it say that once this limit is reached, no more snapshot can be taken. So that's a hard limit. And we also have a soft limit. So it's a percentage value of the actual hard limit. So if you have 90%, after the 90% of the time you get a warning. But the snapshot will continue. You can go until you hit the hard limit. There is another option called auto delete. That means once you enable that, the moment you hit the soft limit, it will start deleting the older snapshot. So it will, most of the time it will never hit the hard limit, and it will automatically delete the auto snapshot. Activate or create. So right now, whenever the snapshots are created, it is deactivated. So this can enable you to change the behavior and say that okay, it should be activated by default. So these are the cognitive options. Basically, I like to emphasize what work we need to do in future. So right now, the snapshot functionality is very hard-coded to use the backend LVM. So since we plan to support various backends, so this particular option should be very pluggable so that you can bring in any other component like Bhat or a GFS where we can use the inherent snapshot functionality instead of just relying on LVM. So we want to make it a little more modular where you can just use any third-party snapshot functionality and still deliver the feature. Other important part is resource consumption. So as I said, when you take a snapshot creates a volume. So it has all the resource or the resource consumption of a regular volume. So normally as a use case, your volume is needs so much process to deliver something because it is being naturally accessed. But snapshot is not the case. Snapshot is generally speaking, the access would be very limited. So you want to recover something, the I/O may not be that far. So you don't need such a heavy resources like so many processes per break, so many ports to be open. So we can just think of to reduce that part. So there are many ways to do that. One of the easiest way is that we don't activate all the snapshot by default. So activation means just like the volume start. So right now each activation means it's creating that many resources, that many processes. So we don't activate all this by default. So what there is a proposal, what we are thinking of is that USS is one of the prime use case by which you can access it. So we can provide a way saying that for a user of USS, most of the volume snapshot will appear as activated, even though it may not be activated. So when you go into .snap folder, as Bhat said, so you have a list of snapshots. So maybe out of that 5 or 10 might be activated. So when a user tries to access a non-activated snapshot, the request comes to the back and the backend will activate it in the background and then provide access. The first access might be a little slower, but the subsequent access might be faster. So, and we can manage a pool how much might be activated. So we need not activate the entire 256 snapshot at a time. So that is one of the way. Other way is to have various retention policies. So right now, as I said, there is scheduling options. So scheduling means you can schedule hourly snapshots, you can have a monthly, weekly snapshot. So like say hourly snapshot means very frequent snapshots, so number of snapshots will grow like anything, weekly will be less. So you can have various retention policies per schedule, so that you can say, okay, these are my schedules which is hourly, so I should have a limited number, monthly be 9 weeks to a longer retention period. So you can have a retention period based on you need to keep that snapshot or do you want to keep it activated. So various combinations of that. So that will give more control to the admin, because admin does judge how much resources he has, how well we want to manage that. So that is also one of the way where we can reduce the resource consumption. So other way, just thinking to have a single process to manage the bricks instead of each brick managing, each process is managing an individual brick. So we can somehow multiplex so that because it is access, it's not very frequent, but it will be a little more complicated. So I'm not given a detailed thought on that, but that is also one of the options. Another thing is migrate to liblvm. Right now we are using hard-coded commands. So that means we are executing commands when you run them. So that is very restrictive in nature. Liblvm supports most of the functionality. So I think we should migrate to the liblvm in the next releases. So these are some of the few works which we are planning to take. Apart from the custody changes which is required to make it much more modular, and also there are a few functionalities still missing. Like we don't provide support for freeware applications.